Welcome to a short guide to analysing horse feeds, understanding which key nutrients to test for and analysing results. So why are feeds tested? They provide a large amount of key nutrients in the daily diet. In some cases, the feed can be over half the daily diet by weight, and the contribution for certain nutrients is almost exclusively dependent on the feed rather than the forage. There may be a health concern, or it may just be a case of good housekeeping. In the case of a health concern, a feed is tested to ensure it is providing the nutritional profile as expected. For example, a feed may be tested to confirm if it is providing adequate calcium or copper for bone development, or perhaps tested for starch and protein to confirm it is suitable for horses with muscle disorders. Feed testing can often be a source of concern, as the results found on analysis will rarely exactly match the values on a feed tag. It can therefore be hard to know what is normal for a feed and when a feed is truly outside of normal range and potentially problematic. This short guide will look at why this occurs and what you can expect when analysing a feed. So what to test for? Feed is most commonly tested for the basic profile as declared on the feed tag. This includes protein, oil, fibre and ash. Additional testing is then dependent on nutrients of interest. Outside of protein, oil, fibre and ash, starch is the most commonly tested for core nutrient. When it comes to minerals, the most often requested are calcium, phosphorus, magnesium, copper, zinc and selenium. And with vitamins, the profile is normally vitamins A, D and E. Results. What can you expect? The values declared on a feed tag are unlikely to be seen in the lab results, so why does this happen? The core nutrient values are derived from the raw materials, which as plants are naturally variable. We will look at a typical horse feed and how the ingredients contribute towards the values seen on a feed tag in the coming slides. The mineral values are also influenced by the naturally occurring levels in raw materials. The dependency of each mineral on contribution from ingredients is, however, highly variable. Some minerals are provided dominantly by the vitamin and mineral premix, such as zinc and selenium, and can be more consistent. Minerals listed in the additive section of the feed tag are just the minerals provided by the premix and do not include any natural levels provided by the raw ingredients. For most of the microminerals, which are the minerals provided in smaller amounts in the feed and normally expressed in milligrams per kilogram, the majority of what is found in the feed comes from the premix. The exception to this is iron. Plants are naturally low in minerals such as copper and selenium, but are naturally high in iron. A feed may only contain, for example, 20 milligrams per kilogram of iron from a premix, but when tested will return a value well over 100 milligrams. Plants and forage can easily contain more than 100 milligrams per kilogram of naturally occurring iron, which is not declared. The vitamin values are additive only values. Vitamins are different to minerals and they are not stable, deteriorating over time. The process of making horse feed will also cause a small loss at the start for most vitamins, as high temperatures are needed to ensure the feed is adequately cooked and digestible for the horse. When testing a feed for vitamins, the content will normally be lower than the feed tag and will continue to change over time. Results. What to expect in a report. A lab will report an exact number as found in the sample sent. A nutritionist will then report that number within a range against the value found on the feed tag. Tolerances or ranges exist in feed legislation for all nutrients. These ranges allow for the fact that variation is naturally occurring and other sources of variation can also influence results. There are four major sources of variation in a feed analysis. These are ingredients, sampling, feed form and the lab. The ingredients used in feeds are plants, and their nutritional value will vary from field to field and from year to year, subject to growing conditions. Feeds also use co-products or byproducts from the human food industry. For example, wheat feed is a co-product of flour milling. The extraction and processing of such products will also add variation in addition to naturally occurring nutrient profiles. Sampling. Feed sent for analysis are often a grab sample, meaning just one sample is taken. As feeds are variable, multiple samples are needed from multiple bags, much the same as when analysing pasture, where samples are taken across the paddock. To get a better picture of the feed, several samples are needed, normally a minimum of 6 samples created from gathering small samples across multiple bags are needed so that an average feed value can be determined. Feed form. Cubes are generally more consistent in profile across a batch of feed as all ingredients are ground to the same particle size and mix evenly. Muesli feeds that contain flake cereals, different sized pellets and occasionally grass chaff will have a higher degree of variation across a batch, as mixing of different shaped and sized ingredients is more difficult. The lab. Variation exists between laboratories and there can be different methodologies used. For example, starch can be analysed by 2 different methods. One is more relevant to the plant and the other more relevant to the horse. Depending on the method used, the results will be significantly different. Feed ingredients are the main source of variation. We will look at 2 core nutrients as examples. The 2 core nutrients for which a feed is dominantly chosen are protein and starch. We will have a look at a typical feed to see how the ingredients used provide protein and starch in the diet and how these ingredients can vary in their nutrient profile, which creates variation against the feed tag value. Here we have our example feed. There are 13 ingredients used in this feed, all make a contribution towards the total protein value. The feed tag value is 13% crude protein. The range allowed for the feed when tested is from 11.37% up to 14.62%. The ingredients making the most contribution are soybean meal and wheat feed. Oat feed makes a moderate contribution at 10% of the total protein provided. Now we will look at starch in the same feed. The feed tag value is 17% starch. The range allowed for the feed when tested is from 11.05% up to 22.9%. The ingredients making the most contribution are wheat feed, oats, barley and oat feed. In both examples for starch and protein, we can see that although all ingredients play a part, some are more influential for one nutrient than another. If these ingredients vary and are different to the value used when calculating the feed value seen on the feed tag, the actual value as found by a lab will be different. How variable are ingredients? In the example diet, the materials making the most difference to protein were soybean meal and wheat feed, and for starch, wheat feed, oats, barley and oat feed were the most significant ingredients. So how variable can these ingredients be for those 2 nutrients? The table below shows the average protein and starch value and the range of values seen when analysed. Although co-products or byproducts are often described as variable in comparison to whole grains such as oats, there is still a high level of variation found even within a whole grain. If we look at 2 examples, oat feed being a byproduct and oats being a whole grain, we can see that both types experience variation. Looking at starch, oat feed has a starch average value of 7.9%, but this could range anywhere from 1.2 to 32.6%. Oats equally experience variation, their average starch value being 36.8%, however this can vary from 26.5% anywhere up to 52.4%. The high level of variation seen within a traditional straight such as oats is part of the reason why most yards choose to use a compound feed that has multiple ingredients. such as our example feed that used 13 different raw materials. By using multiple ingredients, the risk of seeing a very high degree of variation is reduced, as no one material can dominate the feed, but variation will still exist, as the ingredients used will naturally experience variation. To summarise, when analysing feed, ensure that the sample is representative of a number of bags of feed. Ideally, send more than one sample for analysis to get a clearer picture of nutrient profile. Be aware of variation and expect results to be within a range and not exactly matching the feed tag. With vitamins, be aware that there is no range to report against and that values will be lower than the feed tag in the majority of samples.